Okay, hopefully you've already watched the video on solving quadratics by graphing. Now I'm going to show you the second video that you need to watch today, which is solving quadratics by factoring. Again, we're looking for where our quadratic crosses the x-axis. It could be, again, 1 point, could be 2 points, or even every once in a while we have one that doesn't cross at all. So today we're going to look at three different types of equations and how to solve those. So the first one we're going to start with is f of x equals x squared minus 81. All right, so what we want to do, first of all, is we're looking to find the zero, so we want to replace f of x with a zero. So 0 equals x squared minus 81. If you remember back, now it's been almost a couple of months ago, but we looked at how to factor polynomials. And in this case, this is a quadratic. And if you remember, we looked at what we called a difference of squares. It was a situation where we had a perfect square like x squared in the front. We had a perfect square like 81, and they were separated by a subtraction symbol. So anytime I have a perfect square that's separated by a subtraction symbol, I go through a quick little process. So the first thing I want to do is create my two binomials, and then I want to square root both terms in my difference of squares. So I'm going to square root x squared, which puts an x in each binomial. Then I want to square root 81, and I want to put a 9 in each binomial. Now, because of the minus, I've got to make one positive and one negative. So now I have 0 equals x plus 9 times x minus 9. Now what I want to do is I want to break each binomial separately and set them equal to 0 to find the solution. So we've got x plus 9 equals 0. Okay, the idea here is we want to figure out what number, when added 9 to it, gives us 0. If you're not sure what that is, you can always follow the simple rules for a one-step equation by subtracting 9 from both sides. So we 0 out, and x equals a negative 9. All right, we're going to do the same thing with our second binomial, x minus 9 equals 0. Again, we want to think of what number, when 9 is taken away from it, equals 0. You might have an idea what that is, but if not, again, we can do the same process. We can add 9 to both sides. Our 9's 0 out, and we're left with x equals 9. So our two solutions to our quadratic are found at negative 9 and positive 9. All right, moving on to a second example. Okay, we'll call this one g of x. Okay, g of x equals x squared minus 9x plus 18. All right, again, we want to replace our g of x with a 0 because we're looking for the zeros of our quadratic function. All right, and if you were in my class, and even in Mrs. Trejo's class, we learned how to use the x. If you want to do that, you're more than welcome to. Again, the x is found by multiplying the a number, which in this case is 1, times c. So 1 times 18 is 18. That goes on top. And on the bottom is our b, which in this case is a negative 9 or a minus 9. All right, so we're looking for two factors that multiply to make 18, but add together and make negative 9. Now, because my back number is positive, I know that both of my binomials are going to get the same sign. So I look to the middle, and it's a negative. So that tells me that both of my numbers are going to be negative. So I need to find two factors of 18 that add up to 9. Well, I've got 1 and 18, 2 and 9, and 3 and 6. If I add these together, I don't get 9. If I add these, I don't get 9. But if I add 3 and 6, that equals 9. Or in this case, negative 3 and negative 6 equal 9. So negative 3 plus negative 6 is negative 9. Negative 3 times negative 6 equals 18. So those two numbers satisfy both rules that I have to follow. So I write my binomials, x minus 3 and x minus 6. Again, setting them equal to 0. And then once again, I work on them one at a time. So x minus 3 equals 0. So what number minus 3 equals 0? Again, I add 3 to both sides. 0 out, so x equals 3. And I do the same thing with my other binomial. X minus 6 equals 0. I'm going to add 6 to both sides. 0 out my 6's, so I'm left with x equals 6. So again, I have two solutions. My graph is going to cross the x-axis at 3 and at 6. All right, so there's two examples. All right, we're going to finish up with one more example. We're going to call this one h of x. For h of x, we're going to use the equation 2x squared minus 9x minus 5. All right, now, again, we're going to start by creating our x. Well, first, I guess we need to write our equation when it's equal to 0. So 0 equals 2x squared minus 9x minus 5. And now we'll create the x. Again, the top is found by multiplying the a times c. So 2 times negative 5 is negative 10. So I need something that multiplies to make negative 10. And then I need it to add to negative 9. All right, looking at the back of my quadratic, I have a minus. The only way to make that happen is if we take a positive times a negative. All right, and then I want to think of all the factors that make 10. Well, there's 10 and 1, and there's 2 and 5. And in this case, I want them to subtract to make 9. Well, 5 minus 2 is 3, 10 minus 1 is 9. So that's what I want. And then looking down here, I see that I want it to be negative 9, so I want it to be negative 10 and positive 1. 1 times negative 10 is negative 10, and then 1 minus 10 is negative 9. Again, these two factors complete both rules. All right, so we have x plus 1, and we have x minus 10. Now, we're not finished because x times x cannot equal 2x squared. So this is the point where we have to remember to come back and divide by the number in front of x squared, which in this case is 2. Okay, so I look. If this does not divide evenly or simplify, then I need to bring the bottom up to the front. So this binomial becomes 2x plus 1. And then I come to the other one. Negative 10 divided by 2 divides evenly, so this one becomes x minus 5, because 10 divided by 2 is negative 5. All right, set those both equal to 0. And again, I follow the same pattern I followed all along. 2x plus 1 equals 0. I'm going to subtract 1 from both sides. Those 0 out, so I'm left with 2x equals a negative 1. All right, now we have a two-step equation, so we want to divide both sides by 2. So x equals a negative 1/2. So there is one of my solutions. Okay, now I come over here, and I've got x minus 5, and I want to set that equal to 0. I want to add 5 to both sides. So x equals 5. All right, so we have two solutions. Again, negative 1/2 and positive 5. So if I were to graph this equation, my graph is going to cross at negative 1/2 and at positive 5. All right, I thought of one more that we probably want to see just to be safe. So we're going to start with one more equation. We're going to call that one j of x, and we're going to have, for j of x, we're going to have, let's go with x squared minus 7x. This is a situation where we don't have a c. We have an ax squared minus a bx, and so we want to see what to do here. So the first thing I notice is that both terms have an x value. So what I want to do is I want to factor out the x. So I'm going to take and divide out an x from both. So x squared divided by x, we're left with x. And then negative 7x divided by x, we're left with negative 7. And again, we want to set those equal to 0. So essentially what I did was I came in here and I divided both parts, divided by x, and then I put what I divided out in the front and what remained inside my binomial. Now I'm going to set each thing equal to 0. So x, the first part right here, is equal to 0. That's automatically one of my solutions. Then I'm going to do x minus 7, and I'm going to set it equal to 0. I'm going to add 7 to both sides, and now x equals 7. And again, I have two solutions. I hope this helps you out. Feel free to watch this as many times as you need. Again, this may not be every example that you come up against, but this should be a good variation of examples that you'll encounter as you work through solving quadratics.